Good day, everyone. Today we're going to talk about gas laws. Now, the first two topics we're going to talk about is the Boyle's law and the Charles law. Now, what are gas laws? Gas laws describe the behavior of gases in relationship to pressure, volume, and temperature. They include several key principles. First, we're going to talk about is the Boyle's law. It says here that at constant temperature, the pressure of a gas is inversely proportional to its volume. Boyle's law relationship and general theorem. Boyle's law is a fundamental principle in gas dynamics that describes the relationship between the pressure and volume of a gas. So for our Boyle's law's formula, it is V1, P1 is equals to P2 and V2. Now, in our visual representation here, it shows that when V increases, the pressure decreases, and vice versa. When the pressure increases, the volume decreases. So it shows that it is inversely proportional. Now for our V, it says is it equals to volume and P is equals to pressure. Now let's have a sample problem. A gas has a volume of 5.0 liters at a pressure of 1.5 atm. If the pressure is increased to 3.0 atm or standard pressure at constant temperature, what is the new volume? So we're gonna look at the givens first. So for our P1 or pressure 1, it is 1.5 atm. For our volume 1, it is 5.0. Now for our P2, it is equals to 3.0 atm. We're gonna look up for our volume 2. So our solution here is V2 is equals to P1 V1 over P2. So we're gonna just transfer our numbers or given. So 1.5 multiplied by 5.0 and over 3.0. We're gonna multiply 1.5 to 5.0. So that equals to 7.5. Now 7.5 divided by 3.0 is equals to 2.5. So for our final answer for volume 2, it's equals to 2.5 liters. We're gonna talk about what actually happened. So the pressure is doubled from 1.5 to 3.0 atm. So the volume was reduced by half from 5.0 liters to 2.5 liters. That shows that the inverse relationship in Boyle's law. Next we're gonna talk about is the Charles law. Charles' law states that the volume of a gas is directly proportional to its absolute temperature when pressure is held constant. At constant pressure, the volume of a gas is directly proportional to its temperature in Kelvin. For Charles' law's formula is V1 over T1 is equals to V2 over T2. In our visual here, it shows that when the volume increases, the pressure also increases. It shows that it is directly proportional. For our V, it is volume and T is equals to temperature. So we're gonna have a sample problem here. A gas has a volume of 4.0 liters at a temperature of 200 Kelvin. If the temperature increases to 400 Kelvin at a constant pressure, what is the new volume? So our given here is V1 is equals to 4.0 liters. T1 is equals to 200 Kelvin. T2 or temperature 2 is equals to 400 Kelvin. We're gonna look for our volume 2 or our second volume. So our solution here is V2 is equals to V1 T2 over T1. So 4.0 multiplied by 400 over 200. We're gonna multiply 4.0 and 400, so that equals to 1600 or 1600. So 1600 divided by 200 is equals to 8.0. So for our final answer here, it's 8.0 liters. So what happened is when the temperature doubles, the volume also doubles because they are directly proportional in Charles' law. In this case, as the temperature increased from 200 Kelvin to 400 Kelvin, the volume increased from 4.0 liters to 8.0 liters. So that is all. Thank you for listening and I hope you learned something. Thank you and goodbye.